Greetings everyone, I am Amit Saxena. What if I tell you that one wrong click, just a single email, could let a hacker steal your passwords, drain your bank account, or lock you out of your own files? Sound impossible, right? But it happens every 39 seconds. Can you believe that? So, guys, welcome back to our free cybersecurity course. This is video 2 in the series where we explore the top 10 cyber attacks that threaten people and businesses every single day. So, let's see one by one. First is phishing, then you have malware variants, then man in the middle, cross site scripting, zero-day exploit, social engineering, data breaches, AI powered and deepfake attacks. Then you have DDoS attacks and SQL injection. Today's video focuses on first and most common, phishing. It's simple, sneaky, and incredibly effective. Make sure you subscribe and hit the bell icon because by the end of this course, you will think like a hacker and defend like a pro. So, guys, can you guess what is this message? Here, the user is asked to verify his or her account because it says your account has been temporarily restricted due to unusual activity. To restore full access, please verify of identity. So guys, have you checked the language? And it is asking you to verify something. So guys, this is phishing, the art of deception, because if you click on verify now button, you will be trapped. So what is phishing? Phishing is a trick where a criminal pretends to be someone you trust, like your employer, your bank, or even a friend, to get you reveal private information such as passwords or credit card numbers, or to make you open a harmful file. The hackers doesn't break in by force. Instead, they trick you into opening the door. Phishing messages often look completely real with official logos, signatures, and names, but they lead you to a fake website or install malware on your device. So, malware means malicious software, programs made to harm, spy, or steal. Some malware types you will hear about are like keyloggers, where programs that secretly record what you type, like password or messages. Second is ransomware, software that locks your files and demands money to unlock them. These are common payloads used in phishing attacks. The word phishing comes from actual word phishing, where you actually do the phishing with a real fish. Because the hacker throws out bait in real phishing and waits for someone to bite. Once you click, your data is the catch. In real fishing also, when a fish bite the bait, the fisherman caught it. How fishing is executed? Now that's a question. So let's see. So let's see step by step. The first one is reckon and bait crafting. Second is delivery. Third is interaction. Fourth is capture and infection. And the last one is exploitation. So these are the 5 steps which a hacker use while phishing. So let's see each step in detail. First is reckon and bait crafting. Attacker studies the target, company, logos, tone, typical senders, and creates a message that appears legitimate and urgent. For an example, invoice, password, reset request. Second is delivery. Next, the bait is sent through email, SMS, or even social media DMs. The sender address might look almost identical to a real one, just off by a letter. Third is interaction. This is when you click the link or open the file, hackers often use emotional triggers, words like urgent, suspended, or immediate action required. They want you to act before you think. Next is capture or infection. When you click, one of two things happen. You land on a fake login page that steals your credentials, or a file installs malware like keylogger, which records what you type, or ransomware, which locks your data for ransom. So we are going to discuss ransom keyloggers in subsequent sessions. So stay tuned. The last one is exploitation. Finally, they use what they stole. Now they are using what they have stole till now. Logging into real accounts, moving inside networks, or selling your data online. So this is all they do when they steal your information. This is how phishing often leads to a bigger attacks like data breaches or identity theft. Now, the bigger question, how to detect phishing? So let's see step by step. First one, you need to identify the sender, suspicious sender, sorry. The from address looks off. Example, support at the rate amazon.com. It's not Amazon. If you have noticed, in place of O, the sender has mentioned zero. So that's the spelling you have to first check. This looks real, but it is not. The real one is AMAZON, amazon.com. The display names look real, right? It looks real, but the underlying email domain is different. You need to be very careful. Next is urgent or threatening language. So the language will sound like very urgent and threatening. It will make you act. For an example, your account will be locked in 24 hours. Verify your identity immediately. You will be in a panic situation and you will be forced to act on that message. So please be careful. Then you have suspicious links. Hover and don't click to inspect links. The real URL may lead somewhere completely unrelated, like we discussed in the previous slide. Amazon.com, right? In place of O, they are mentioned zero. The actual is Amazon with O. The real link might lead somewhere completely different, right? So both are different. Be cautious. Then you have unexpected attachments. Be cautious with the file having extensions like .exe, .zip, or .js, or macro enabled files. Macro are small programs that inside Word or Excel files. Hackers often hide malware inside them. So you need to be very cautious with these files, with these extensions and macro enabled files. Let's discuss these extensions a little bit more. So .exe is generally we use for an executable file, a program file that runs code directly on your computer. It can install malware immediately when opened, viruses, trojans, or ransomware. Then you have .zip or .rar file, which is compressed. We use to compress files. Used to bundle files together in a smaller size, can hide malicious executables inside. Attackers often rename .exe file to look like documents, example invoice.pdf.exe. Then you have .js, it's a JavaScript file, a scripting file often used for web automation. When opened, can run scripts that download malware or steal information. Then finally you have .docm or .xls or macro enabled Word or Excel files. These are Office documents that allow embedded VBA, Visual Basic for applications, scripts. Okay, so malicious macros can automatically run code when the document is opened, installing malware silently. So please be careful, be cautious when you see files with these extensions. Okay, next is request for sensitive info. Legitimate companies never ask for password, pins, or credit card details via email or text. So please be cautious. Last is poor grammar or design. As we see in the previous slide, they have typed the address amazon.com incorrectly. In place of O, they have mentioned zero. So you need to be cautious and you know see the spellings and grammar of the language. So misspellings and typos is first example. Your account has been suspended. Legitimate organizations carefully proofread their office messages. Second is awkward or unnatural phrasing. Attackers may not be fluent in the target language, so the writing often sounds slightly off. For an example, we are wanting you to confirm your account now, please. So see the grammar, we are wanting you. So you can just go through the grammar part and easily detect it. Then you have low quality or inconsistent design, blurry logos or mismatched colors. I repeat, blurry logos or mismatched colors, incorrect or outdated branding, poor alignment or layout that doesn't match official company emails. So, till now, we have discussed uh, how to detect phishing in terms, uh, by looking at the messages, the addresses. But now we are going to discuss how we can detect phishing technically using some softwares and other technical aspects. So let's go one by one. Behind the scenes, your email provider uses technical checks to identify phishing automatically. These are called authentication protocols, SPF, DKIM, and DMARC. So let's see what are these protocols. So first is email authentication protocols, and in these protocols, first come is SPF, which is Sender Policy Framework. Okay. Sender Policy Framework is an email authentication protocol designed to help prevent email spoofing. What is email spoofing? A common tactic used in spam and phishing attacks. SPF allows domain owners to specify which mail servers are authorized to send emails on behalf of their domain. When a receiving mail server gets an email, it checks the domain's DNS SPF record to verify if the sender's IP address is allowed to send mail for that domain. Okay. Next is okay. So let's see how sender's policy framework works. So before going to the next protocol, which is DKIM, let's go through the sender policy framework protocol, which we discussed, how it actually works. The first step is the sender sends an email from user at the example.com. Second, the receiving mail server looks up the SPF record in the DNS for example.com. Then this record lists authorized mail servers, IPs or host names. Next is the receiver compares the sender's IP to the list. Then, based on the match, the receiver applies a policy decision. First, it will be a pass if authorized sender is authorized. Second scenario, it will be a soft fail, probably unauthorized but allow with caution. It can be an unauthorized sender, but you are allowing that sender with a caution. Next is fail. It is an unauthorized sender, likely spoofed. So it is trying to spoof you. Okay, going back. The next is DKIM, domain keys identified mail. So DKIM is another email authentication protocol. It helps verify that an email was not altered during transmission and that it actually came from the domain it claims to come from. DKIM work by digitally signing outgoing emails with a cryptographic signature that's tied to your domain. The receiving mail server then uses a public key published in your domain's DNS to verify that signature. If the signature is valid, the message is confirmed as genuine, not modified and sent from an authorized domain. That's genuine means. If it fails, the message might be fake or tampered with. Let's see how DKIM works. Okay, how DKIM works. When you send an email, your mail server adds a special DKIM signature header to the message. This header contains our digital signatures generated using your private key. The recipient's mail server checks your domain's DNS for a DKIM public key stored as a text record. Then the receiver uses that public key to verify the signature. If the message was altered or not signed by the real private key, the verification fails. The receiver marks the message as DKIM pass or fail in the email headers. So what are public and private keys which we have used or we are using in DKIM method? Public and private keys are just long strings of encoded text, typically using base 64 encoding that represent very large numbers used in cryptographic operations. So it looks like this. It's a long string of encoded text. So that's private key. In the similar way, you you have public key, the same encoded text with long strings. Okay, so going back, now the next is DMARC, domain-based message authentication, reporting and conformance. Okay, so DMARC is an email authentication protocol that builds on SPF and DKIM to give domain owners more control over what happens when an email fails authentication checks and to provide reports about who's sending email using their domain. DMARC tells receiving mail servers, if an email claiming to be from my domain fails SPF or DKIM, here's what you should do with it. And please send me a report about it. It's like a policy layer that connects SPF and DKIM results to a clearly action plan. Together, these three work like airport security. So it's an analogy. Please pay attention. Together, these three SPF, DKIM, and DMARC. These three work like a airport security. SPF checks your ticket, DKIM verifies your ID, and DMARC decides whether to let you in or not. Let's see how DMARC works. Okay, you publish a DMARC record. First step, a short text rule in your DNS. Example, V equals to DMARC1, P equals to reject, then RUA equals to mail to reports at yourdomain.com. So it says what to do if an email fails checks. None, just watch, quarantine the mail, send to spam, reject, block it completely. So these are the status. If fails checks, it says none, then just watch it, quarantine, send to spam, reject, block it completely. So that's a rule created. And based on that rule, you decide what to do with the message. Second, email is sent. Someone sends an email claiming to be from domain. Second, receiver checks SPF and DKIM. First, SPF, was it sent from an approval mail server? That SPF checks, that policy framework. Then DKIM checks, was it digitally signed by your domain? Based on first and second step, DMARC checks alignment. Do the results of SPM or a DKIM match you from address? If yes, the DMARC passes it. If no, the DMARC fails. So that's how these policy frameworks, SPF, DKIM, and DMARC works. Now let's see the next one. The next method, which is machine learning and heuristic analysis. Okay, machine learning and heuristic analysis. So what is it? First is machine learning. Modern security tools don't rely on the rules. They use machine learning and heuristic analysis to stay ahead of new threats. Machine learning means training computers to recognize phishing patterns like detecting suspicious keywords, unusual link structures, or new sender domains. Over time, the AI learns what phishing looks like and flags similar messages. Uh, Okay, so let's see how machine learning works. First step, data collection. Okay, emails, URLs, and metadata. Subjects are collected. Next is feature extraction, where machine learning identify traits like sender domain reputation, presence of suspicious keywords like urgent, verify, reset password, then link structures and domains age, and finally attachment types and names, HTML obfuscation or hidden redirects. Then you do model training, where algorithm learn the difference between phishing and legitimate samples. Then you do prediction. The trained model scores new emails for phishing probability. Then continuous learning, where the system improves over time as new samples are analyzed. So let's go back to machine learning and heuristic analysis. So this is all about machine learning and how it works. Now let's see the second part of it, heuristic analysis. Heuristic analysis means rule-based reasoning. So they utilize certain rules for reasoning, and based on their rules, they decide whether it is a phishing attack or it is not a phishing attack. It doesn't wait for a known virus signature. It looks for behavior that feels suspicious. For example, if an email says urgent and includes a link, it will add risk point. If a file tries to change system settings, it will mention it suspicious. Think of it like a digital detective using experience and logic to spot danger. Now let's see how heuristic analysis process works. Okay, the first step is data collection, where the hacker gathers emails, attachments, and web content. Then you have feature extraction, pulls out clues, suspicious words, domains, or code. Then you apply the rule, check those clues against known patterns. Then finally you do scoring and classification. You assign a risk score. Based on that, you classify. Then you do behavioral simulation, where you opens the file in a sandbox. A sandbox is a virtual environment. It's completely independent of the systems you are working. So uh, there we try to simulate the mail which has come from the hacker, uh, and try to see the outcome of it. It is a safe virtual space, and we just use to watch what it does. Here we have used our sandbox, which is actually a virtual environment. It is a testing area actually, where dangerous code can run without harming your real system. So here we are actually testing that mail, that is spam mail. Finally, you have reporting and blocking. If risky, the message is blocked or quarantined. So finally, based on these rules and steps, if we found it risky, the message is blocked or we call it quarantined. This way, even new, never before seen phishing attacks can be detected automatically. Okay. We discussed all these things in details. Okay. So just want to mention how the risk scoring is done. So I'm just going back to this slide. Okay. When we apply these heuristic rules, uh, it's a set of rules, or we call it a rule engine, where we check these features against known phishing patterns. Okay. First rule is If from domain is not equals to reply to domain and the description part is potential spoofing, then action, we add two risk point to it. Second rule is if email contains word urgent plus external link, it's a common phishing pattern. We add three risk points to it. Then the next rule is domain age is less than 7 days. Then description is suspicious newly registered domain. Then you add plus five risk points. And all these risk points contributes to a risk score. So based on that risk score, we decide whether it's a false, it's a legitimate one, or it's a phishing attack. So all rules results are aggregated to form a total risk score. Example, as we saw in the previous slide, we added all the risk score. So let's say the score is 12 and the threshold was 10. If a score is greater than equals to threshold, then we will mark it or flag it as phishing. If the score is less than threshold, we mark it as legitimate. This step balances false positives or legit emails flagged as phishing and false negatives missed phishing emails. So that's how we do scoring and classification. Okay, we discussed about behavioral simulation, reporting and blocking. Heurist okay, here are some heuristic analysis examples. So how what kind of phishing attacks we try to detect through heuristic analysis. For an example, email contains obfuscated JavaScript, so it can be possible phishing web page. If a link domain recently registered, you see it is a recently registered domain, or it completely looks like completely different domain. It can be suspicious message. Message asks for personal data, red flag, because nobody asks you for your personal data. From address is not equals to reply to address. That's something suspicious. Attachment is executable but disguised as a document. It came to you as a document, but in actually it is an executable. And in the previous slides we discussed that executable contains malware. Once you execute it, it will spread malware in the system. Okay, so that's about how you technically detect phishing. Now let's see how to prevent phishing. So first we have learned, you know, what is phishing, then how to detect it uh, by just looking at the messages or emails, then how to detect it technically or using protocols. Now let's see how to prevent it. Now that we understand how phishing works, let's look at how to prevent it. First is enable multi-factor authentication. We call it MFA. Okay, even if your password is stolen, MFA adds another lock like an OTP or finger point. So I think just a minute. Okay. Multi-factor authentication means using more than one way to prove it really you. When you log into an account, instead of just typing your password, you also have to provide another piece of evidence, like a code sent to your phone or a fingerprint. Think of it like having two locks on a door instead of one. Even if someone steals your key, your password, they still can't get in without the second lock. So here you have MFA gives you the freedom of having two locks. One is your password, second is your code, which it sends on your mobile. Then you confirm it, then it will allow you to log into the system. Okay, let's go back to the step. Okay, so let's go one by one. So we discussed multi-factor authentication. Next is train staff with simulated phishing tests and clear reporting paths. Okay, run simulated phishing tests to raise awareness. So keep on running simulations to test and raise awareness. We discussed simulation in previous slide. Use SPM, DKIM, DMRC in link scanning gateways. These block fake emails sent under your company names. So all these protocols help you guys blocking fake emails sent under your company's name. Keep software updated. Update fake security holes that hackers often exploit. Report suspicious emails. Don't ignore or delete them. Report them. Improve filters for everyone. Okay, so that's it about the phishing. Let's conclude what we discussed today. Okay, so now by end of this video, I'm 100% sure you now know how phishing works, how to detect it, and how to protect yourself. Okay, guys, so this is about the video. Now, in the next episode or next video, I'm going to discuss the malware variants. So stay tuned and do see this video because it is going to be very interesting. Here we are going to discuss different kind of malwares and their attacks. Okay, so malware also covers, viruses, worms, trojans, and ransomware, and see how these programs spread in attack systems. If you found this video helpful, make sure you like, share, and subscribe because knowledge is your best defense. So thank you guys. This is all. Let's see you all in next video. I hope you like this one. Uh, till then, please take care of yourself. Thank you so much.